morning, class. As you know, I won't be here this week, but class must go on, and I really didn't want us to waste a week with some handouts and review stuff, so I'd rather us go ahead and move forward. And to do that, I'm taking some time to actually build videos, um, kind of what I would normally say during a lesson, and hopefully your teams are strong enough that you can continue from where I leave off. So you're going to see these for this week, both in math and science, and hopefully this is meaningful and works well. I decided that we actually are going to keep doing our homework on Classroom. I'm okay with you using your phones in class. Please, please don't abuse this. If the substitutes are not comfortable with that, I'm fully okay with you using the textbook, because the problems are still in the textbook. So that's perfectly fine for class if they choose. I'm okay with that. Whatever they want to do, they're the ones who are actually in the classroom dealing with it. If you guys are not being responsible with your phones, that's really on you. So please respect them and don't take advantage of the situation. Okay? So let's get started here with 211. 211 introduces algebra tiles, which should be a concept you remember from 7th grade. In 7th grade, the algebra tiles were fewer than they were before. So what I'd like to have happen right now, please, is for our substitute to pass out one set of algebra tiles to each group. When you get your algebra tiles, do not dump them on the table. Okay? Leave them in their bags. We're going to go through and just pull out what we need as we go with the algebra tiles, okay? If you dump them on the floor, it's going to create a horrible mess, and I'll have algebra tiles on my floor for the next 2 months. Seriously, okay? So please don't just dump them out. Wait until I tell you what to do with them, okay? So go ahead and hand those out now. I'll go ahead and wait and pause the video. Okay, hopefully you all have your algebra tiles now. Let's go ahead and start talking about them. In problem 211 and 212, it's really a matter of getting used to the ideas of these algebra tiles. There's a few things going on here. You should have 6 tiles, or 7 tiles total. You should have a 1, a unit tile. You should have 2 different rectangles. Okay. You should have 2 different types of squares. And you should have this kind of largish rectangle. Okay. The smallest square is what we call the unit tile. It's a 1. The next set of small rectangle there, and the square that has the same side, that's our x's. If you notice, you can put the 1's tile and the x tile next to each other here. You'll see that one side lines up perfectly. But no matter what you do, you can't make the other side line up perfectly. And every year I get some kids who try to tell me, oh, well, it's 2.5 tiles, or it's 2.25 tiles. And the truth is that the tiles don't line up on purpose. Okay? This is on purpose, that one side is 1 on the x tile, but it's also on purpose that the x side cannot be built out of 1's. And there's a really good reason for that, and the really good reason is that we don't want x to have a value yet. X represents a variable. Later on, we're going to give x various values, right? Could be 100, could be 1,000, could be 5, could be negative 15, okay? Could be all kinds of numbers. So you don't really want to have algebra tiles that conveniently line up exactly, because it can send the wrong message to folks when they're using the tool. So the smaller rectangle is x, and there's a square that's the same size, and that square is made out of x tiles. As you can see, flipping it around there. So that's an x by x, x squared. We name algebra tiles based on their area. Okay? So the 1 tile is a 1 by 1. 1 times 1 is 1. The x squared tile is an x by x, gives you x squared. And the x tile is a 1 by x. Okay? We also have a y tile. Again, bottom side is 1. This length right here, we're going to call y, and we can't build y out of 1s. The fancy word for this is non-commensurate. These tiles are non-commensurate because you can't create one of them out of a combination of the other. Okay? Y cannot be built out of 1s. Y cannot be built out of x's, and that prevents that confusion. There is, of course, also a y squared tile, which is y by y. And finally, there's an x by y tile, or the xy tile. Okay? That's your other new tile that you're going to be looking at this year in Advanced Integrated 1. The third problem is called jumbled tiles. Jumbled piles. So this is a jumbled piles problem right here. I'm not going to have you do 2-3. I'll show you how 2-3 works up here. What 2-3 does is points out that you could pile all the tiles of a certain type together, and if you did that, then it's really easy to see the value of the tiles that you actually have. And it's literally just this process of sorting through them and putting everyone together. And that particular pile had 7 1s, it had 3 y's, had a y squared, 2 xy's, 2 x's, and 4 x squareds. You notice that it becomes much more nice and organized when you set everything up. Same thing happens with problems. Okay? So if you're looking at a math problem like you see these guys down here, these I'd like you to go ahead and build when you get time to when we start doing the actual in-class exercise. But when you see this, you're going to see, wow, that's really chaotic. And then you put it together and everything's nice. Okay? And when it's nice and put together, it's much easier to solve. That's the whole point. This is what's called combining like terms. Okay? If we go to 2-1-2 real quick, you can see that there's a few things here. In 2-1-2, specifically problem 211, we want to start talking about the perimeter of each tile. The perimeter. Okay? Perimeters are a little bit different than areas because you're walking around the object. Okay? So the perimeter of this y tile here would be y, 1, y, and 1. Okay? And it's fine to write it like that for a second, but think about a way that I could make that more compact and a little more simple to work with. And realistically, if you said y, 1, y, 1, what you really have here is 2 1s, 2 y's, so that's 2y plus 2 is a more compact way of describing that perimeter. Okay? Over here we have x, y, and you'd probably want to call that an x, or 2 x's plus 2 y's. Okay? Here in 2-1-2, we start practicing that combining like terms a little bit more, and the idea here is to take A through G, match it up with 1 through 7, and find the like terms. So here we have 3 x's, come down here until you find something that has more x's, and you're like, oh, well, 3x plus 5x, well, that's really 8x. So it's kind of like a jumbled tiles problem in a way. The real piece that you care about is the variable. Okay? If you contain the same variable, including the exponents. Remember, x's are different than x squareds. They're different than xy's. Okay? A to the fourth is not a squareds. But I can combine all the a squareds, I can combine all the a to the fourths, and that's actually really awesome. Down here, 213 and 214, these are probably the most important problems of today. 213 introduces this concept that we could build some shape out of algebra tiles. Here it's this really long rectangle. It's built out of 2 x's, 2 1's, and a y. Okay. Now if I were to look at the perimeter, you'd have an x, 1, y, 1, x, 1, x, 1, y, 1, x, 1. Okay. Combine all those like terms, create a much more simplistic version of that. There's 4 x's, there's 2 y's, there's 1, 2, 3, 4, 5, 6 1's. This is 4x plus 2y plus 6. Okay? Where it gets interesting is part B. Part B, you got this one tile lying against an x. Okay? So this length is x, this length is 1, 1, 1, 1, 1. What's this length? Okay. You have a length of x, but you got to subtract off a 1. So we would call this length x minus 1. If there had been 2 unit tiles, we would have subtracted off 2. If there had been 3 unit tiles, we would have subtracted off 3. Okay? So x plus 1 plus 1 plus 1 plus 1 plus 1 plus x minus 1, you simplify that out, you have 2 x's still. Okay? But then you have 1, 2, 3, 4, 5 minus 1 is 4. And the answer for B is 2x plus 4 is the perimeter. Alright? That problem and the problem below it where you're actually giving values for the x tiles and the y tiles, these are going to be on the test. Okay? So 213 and 214 are perhaps the most important problems to talk about with your group and try to understand. Especially look at problems like D. D and C are very good problems for me to put on the test. Okay? There's something very similar to one of those two on the test, I believe. Again, we're going to do homework through the forms, so check Google Classroom if you haven't. Some of you have already done it. We had to push back a day last week, so the homework for this section has already been online. So go on there, complete that up if you haven't. Otherwise, in your groups for right now, I'd like you to start with 2, 1, 1. Go ahead and work through 1 through 4. Or actually 1, 2, and 3. 4. We did 3 together. This learning log, I'd like you to start these. I'd like these to go into the quick writes section of your binders. So I believe that's the last tab in the binder. It says quick writes. Wherever you see a learning log, I want you to put those there. I want complete sentences. I want you to give it some thought. There's no minimum requirements for sentences. I would say most of these can be done in 3 to 5 sentences. If you can say it succinctly, good for you. If you need more sentences, that's fine too. As long as you answer the question, is what I'm going to say. 212, I'd like you to work through 211, 212, 213, and 214, and then once again I want you to do this learning log, 216. Skip 215, that's a pretty rough problem. Those of you who feel like you really want to challenge yourself and that this was too easy today, go ahead and give 215 a shot. I will make that an extra credit problem if you want, so do it on a separate piece of paper so you can turn it in. You got to hang on to it until I come back though, okay? Hang on to that until I come back, which will be next Monday. Alright, that's the lesson for today. Go ahead and have fun working in your groups. You have the rest of the class to finish just a few problems. So hopefully you get that all done and get to work on the homework piece. If you're done with the homework, go ahead and start doing homework for another class or some other quiet activity like AR till the end of class. Have a great day. Look forward to seeing you guys soon. Bye.